Hello and welcome back to part 6 of learning about Unreal Engine file formats. Last time we already finished TOC files, and this time I want to focus on the PAC files. PAC files I already know. My tool already supports PAC files of Unreal Engine 4, and as far as I've read, they don't differ that much from the Unreal Engine 5 version of the PAC files. So I just grabbed the first one and put it in the hex editor and can already pretty much read the header of it without looking into the code. Of course I will peek into Q4Parse to see to look for hints if I get stuck, but I'm pretty sure I can get this done without. First off, they seem to use, so the game I'm working on, Split Fiction, is using the default PAC file magic, which is 5A, 6F, blah blah. So we have 5A, 6F, blah blah. And already that's the start. I know there's a byte before it, which tells if it's encrypted, which is 0, so it's not encrypted. This is the engine version. This is the offset of the index for the files, and this is its size. I assume this is the hash. That's a good question what this is. Just to guess anyway. And then we have a string that contains compression methods, it seems. And I'm pretty sure they are always 32 bytes in size. So this should be 10 of them. Sorry, 16 bytes in each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that's the whole header of these PAC files. Not so hard. Let's actually put this into my tool then. I already have PAC file classes for Unreal Engine 4, but let's make new ones for Unreal Engine 5. So first off we need a PAC file. So PAC file. Okay, let's have a look at mine. In fact, actually we'll just probably copy out everything and adapt it. This will come in a second. PAC file, game hint. And this is Unreal Engine 5 PAC file. Okay, fine. So we need a header. At least that's how I call it. Let's copy that from here because it's pretty similar. Okay. That's wait, that's a source. PAC file table. Should also be pretty similar. Yeah, this will have quite a few edits. Okay, so now we have our PAC file. File table of the decrypt file table, entry data, Okay, so we have to implement these methods, and the first thing I want to add here is a pack file, is a table for lookup offsets. Public dictionary game hint and offset. Oh no, this doesn't get a name. Offset. Header offsets. So for our game, that would be game type. Never mind, not hint type. Split fiction, and I think it's CD. Okay, sorry. And why is this not okay? Oops. And what I'm interested in, if this is the same for the other files as well. So let's open a few. Go to the end of it. It's CD. It's CD. And so on. That looks pretty static. If not, I will see it in a command line console output that it didn't work for that. And I have to find the game type none. Okay. So if offsets has contains key offset equals oops. Okay, otherwise I don't know, try another one. Hard code this. Okay. If the file is smaller than its position can only be long. Ah yeah, 32-bit was a problem with yeah. can probably make this long then too. Just having overflow. Because otherwise the biggest file in 32 bits you can access would be 2 or 4 gigabyte, I'm not sure. Okay, so now we go that far back and we try to read the header. And I comment out that for now. Okay, so let's try to actually read a header. So in this case I would know the size. So also offset, this is just relative to the end, this won't be a big number anyway, this can be just an int, even 32-bit, the header won't be 2 gigabyte in size. Alright. Okay, and now there are 2 attempts to read this header, because in Unreal Engine 4 there are some special cases to handle there, like decrypting it or something. But we try normal first. And I don't have a special case yet, so I'm not implementing it. Okay. And encrypted magic. Hint.magic. Hint.magic. Yeah, do we actually have that defined? No, not yet. Magic. So in this case, that would be this. Okay. Min and max version, well, I don't know it yet, but as far as I can see it's B. So min and max would be just do it in hex. There's no special key involved here. Okay. So we have the version, then we have the offset, then we have the size, and 20 bytes of SHA-1, that's definitely too much. Oh no, actually, let's take 20 from here, it includes this 0A. Then it fits, and this is a fixed byte array, a fixed array. Yeah, how many are these? Compression name length 32. Okay, so it's not 10, it's 5. All right. So we read the SHA-1, and now we also need to read the compression names. I did this before. So that's what I want. Okay. Okay. Is the count also fixed? Well, okay, I can just calculate it as a count. So, because so far we read how many bytes? 2D. Oh, I don't need the size, I have the size. Okay, so now we have the size and divided by 32. So, compression, new array of that size. Okay, and now let's read it. I just assume it's UTF-8. Okay. Okay. Let's initialize the method to none. And if we can actually parse it, check. I'm not sure if this can give a big null, but just in case. And then we have the compression methods. And then we have our header read. Isn't that great? Okay. Now let's actually test this. First off, I want to change something. when we actually load files, for now I want to skip all of them that end in TOC. Okay, first we have to actually expand our wrapper. To have packages for UE5. So you know also the reference to that. Okay. So now we need here a store. And the pack file. At what point do I actually filter for endings? Talk. Okay, let's try this. Why can I not call this pack? Okay, pack 5. So rename this to pack 4. Happy now? Okay. If pass dot ends with utalk if it ends with pack, then this is pack 5. this can be null. Now we also want to have packs. Which will never be true for now, but it is fine. It's just about testing. Can I please have this indented? Yeah, that looks better. And I don't want to actually execute this for now. I just want to execute this. Oh, that was a little bit of work, I'm sorry. But let's go on. Try it out. Oops. Hello, Visual Studio, please talk to me. Okay. Hello Unity, what are you doing? Did it finally? Still not. Stuff to cut. Okay, I'm back. This import took a while and I probably will cut it out. I don't know, Unity sometimes just is slow. Okay, load a folder. And here we are. Okay. Should definitely be false. Magic is correct. Version is correct. offset and size. Okay, let's actually go there. Oh wait, what was the actual file? Okay, it was the first one, okay. Interesting. But definitely, oh yeah, here's the mounting path. That looks good. It's opened by another process. How come? Looks fine to me. Ah, probably because I have it open now. Then let's make some notes. That's the address. And this is the size. Oh. Okay, and let's just continue. I see no crash. I don't know. This is a lot of data. What I don't see is file names. Okay, let's have a inspiration from the guys that already figured this out. So, pack info, okay. Read the pack info. Let's try. F pointer archive. What is an pointer archive? Read at, async, seek. Okay, interesting. This is just info that really just reads. Wait, what does it actually read? Oh, it actually. Let me read. So, index offset. Sure, that's what we just read. And its size. So, what are we doing with this? Go to Aftermath. At some point we have to read the mount point. result for compression. At what point? This is not right here. Wait, what? Yeah, this is really just the header. Okay, so let's continue in the pack file reader. Yes, read the extract. Mount, yeah, that's the part I'm looking for. If it's bigger as 10, definitely it is. Read index updated. Read and decrypt. Well, we know there's nothing encrypted, so that should be fine. Mount point. Read F-string. Primary index. So that's where we add here in the hex editor. The first thing is a string that has the mount point. So far so good. No passes index. Read int. That is a file count. It's pretty little. Pass hash sheet. Okay, then this is a seed. Then we read a boolean. It's supposed to be 1. Yes, it's this one. Oh, never mind. Read an int. That was this. This is a file count. Then we have primary path hash seed. What a damn word. 8 bytes. Okay, that's fine. And then we read one boolean. That should be 1. Great. And we just advance for 36 bytes. Okay. Now we assume find another one, but it's not that far away. It's only 7 away. Well, okay, we have more of them. I go ahead and say we need one more. It's 2011. offset and size. Okay, this is not matching at all anywhere. Offset and size. This could be an offset, this could be a size. Actually, let's try that out. Isn't it right behind the data we just copied out? Quickly mark this. And we end with 8A09, 8 bytes before it. Yep, that is right after the index table. Okay, so this is the offset for hash index offset. Directory index hash. What's this? Or could be this. Also looks like a hash. And then this is a directory offset. Well, close. Definitely somewhere where file names are. Or right after it. And it actually looks correct. What's the stuff above then? Ah, never mind. So above these are all the directories and below these are all the files. I remember. Okay. Whew. Well, I have to do a little cut here and take a break, and then I will continue right after that. Okay, I'm back. As you can see on the clock, a little bit of time has passed and I had some time to actually look into the code of what's ahead. And now I know a little bit more and we can just continue. So the data we just cut out, the primary index data, so far it's correct, and I went through the reading part here again and it actually fits, so I did a little mistake before. So let's see how far we have it. Bug file table, bug file. No, that's Unreal Engine 4. Is this also 4? Okay, so we have the header, which tells us compression methods, offset, size. Great. Let's get that stuff. Okay. Don't have implemented encryption yet. Get entry data. This is for last. Okay, so we have to fill our pack table. When you go into this, Unreal Engine 5, yes. Pack file entries, we will have C still. I don't see why we make a new stream here, if it's already a copy. So we can directly work with that. And we can directly start. Okay, the mount point is a Unreal string. Very easy, it's just length and the data. Okay, next comes the file count, that's still the same. Okay, then we have to, let's check this here. So far it's the same, file count. Some seed we have to skip, that's the next 8 bytes. Then then we read the Boolean 32-bit, which is kind of wasteful, but well, I didn't implemented it. Return. I can actually make a valid check here too. And initially false. Okay. So we expect this to be true. Yes. Then I already found out what the stuff afterwards is. And say just skip it. So 24 bytes in hex. It's 36 actually decimal bytes. Then we need another boolean that should be true, so that's fine. So we used up that. Now comes the important offsets. So this is called the directory offset. And size. Actually read that. I'll actually do that later. We first gather more information. Next offset. Yes. That's okay. And we confirm that. That's the directory offset, directory size, and we skip 20 bytes. That's 14 in hex. That's some hash. And then we get already the size of the peg entries. Yeah, just peg entries. And peg entries size. And we can directly read those. That is okay. And it's kind of tricky. So let's see how much is left in this buffer. This is 1094.44 and we have 1094.40. So the last 4 bytes are actually something else. This is files num, which is 0 here for some reason, but yeah. So we can skip that. Just expect it to be 0. So let's read them. Let's see, read. Okay. Memory stream. I have a bad feeling right now, but for another reason. It finishes. Peg entry buffer from this buffer we just read, and I actually have one of these. I expect a 0 here. Okay. And if I remember correctly, this is the end of the header data, because that's how much our peg header told us how big it is. Where was the start again? Yeah, that's a magic version number, offset, size. Yeah, that's the end of it. I already know this directory index we grabbed at the very beginning is right after it. That should be the stuff we skipped to this offset. So last 8 bytes. Last 8 bytes. Yeah, matches. So this comes right after that. So I have to be able to go to seek there. Entries, blah blah, files, pool. Or just initializing stuff. first next thing we need is a directory index length, and that we read from this directory buffer. Ui, okay. Files count. No, that's the other offset, sorry. This is right after the header here. We are looking for the directory header. Not quite sure why we're in the middle here, but so file size, so just this already is a later code that will happen here. Directory index length, that's the first int here. Then we have our first uString, that is the folder name, directory name, which has 2 files in it. Another fstring, file number 1. And this has an offset inside the rest of this buffer here. So from here to there, minus the last 4. These are the pack file entries, and that's the offset inside that, where I would have to look for the details of what's actually in the file. That's kinda indirection, that's really confusing, but yeah, this will work in a few seconds, pretty sure. So what this also means, I have to be able to seek the directory buffer. How do they do it? Encoded directory offset. Data. Okay, this has separate functions for it. Okay, I get it. But not a problem. Get file table data. We are in a file stream. So let's use that. S. Okay, Z. So let's cut out the directory size. That's the offset. That is here. And its size is this. Perfect. Okay, let's copy that out. Let's do the same here. Okay, so we seek to the directory, we copy it all in, and we make a new buffer for it. We call it directory buffer. Okay, so if I'm correct, We have everything to combine this now. So that would be directory index. Is this ever used again? Oh, okay, never mind. Okay, let's call this gear count. I think I have to make this shorter. Wait a minute. This is supposed to be file count. Will this ever be used again? It's just for allocation? Okay, I don't need it. Yep. We don't need that anymore. Okay. The account index. Yeah. Reads the name. Reads the count of it. Yeah, that should be easy. Sorry. The name. String. Dear path. Okay. Oh, and file count. Okay. Same idea as here. Okay. Why does it always go into that? File name and offset in the pack. Data. Okay. So string. Okay, now we take our pack buffer and go there. Some security. This should never happen. Okay. And now we can finally read a pub file entry. So what do we need? 1 point. This is just reading the meta information, so I just need the buffer to read from and the actually full file name, which I already have at this point. entries, add new file entry, pack file p, stream file name is our mount point, plus username plus file name. If I am correctly, let's see, so let's go back to the start. Directory. Yeah, they all end with slashes, and then the file name. Sure, the mount point is just a slash, usually. Okay, great. So actually, let's process them. So we already have the path. Why is it not? Okay. So let's have a little look up how they do it. So first we have an offset. Actually, first let's copy this out. I think this was a start. Okay, the first is the offset. This weirded me out initially because this didn't make sense to me. If I actually go there, that is a start of a entry. So this is E0, 0, 0, 0, 0, 0, 0. No, it's 120. Nope. Yeah. Yeah. That's in the middle of the file, and here starts something, so that looks compressed and fine to me. So now we have to pass that in from here. So the offset is correct. So then we have compressed and uncompressed size, which is supposed to be a long, but that doesn't look correct to me. As an int, maybe, but who? Interesting part. Well, that's definitely not a valid compressed size. Why is it long? Okay, I will take another break here and then figure that out. Be right back. Okay, after a longer search into this, they made it really complicated this time. So first off, I was in the wrong code of Q for parse, and everything starts with a bit field. So essentially what they've done is first we have a bit field that tells me if the ongoing, that has a lot of stuff in it. First off, it tells me if the next value is 32-bit or 64-bit. Then the next value, if this is 32-bit or 64. Then in here is in this 8-bit is encoded that well, it's missing here. How do I explain this? Let's see. So this is a 23rd bit. Let's see. E0, 80, ignore the lower part, decimal. We right shift this by 23. Where did I get this from? Here, to get the compression method out of this. So right shift 23 in hex, and then binary end with 3F, so pixel hour 7 bits, and we get a 1. Yeah, so that's the lowest bit here. If this is 0, it's uncompressed. If it's 1, take it from the list of compression methods from the header. So this is already some stuff. So the first thing afterwards is the offset in the file. The second one is uncompressed. It's an uncompressed size. Yes. And in this case, the first entry, for example, has no further, it doesn't have this bit, so it doesn't have compression, so nothing more is read. This is the next flag field. This time we have actually value set here, the 8-bit, yeah, the 8 in hex here tells it's compression number 1, and so we still have offset in the file, uncompressed size, and because now we have compression, we have uncompressed size. This works for the next one. 3 values before the flag. The next one is a little bit tricky. It has this plus bits in the lower area here. If you shift the whole value 6 bytes to the right and only takes the lower 16 bits, that's how many compression blocks there are. They are not relevant for me right now, but they have to be skipped to read this properly. So first off we have again offset, uncompressed size, compressed size. This is a good compression, by the way. And then takes this value again. E0, 80, or 1, 20. Decimal bit shift, right shift, 6. So we get this value, and the lower 16 bit I can already see is just 4. So 1, 2, 3, 4, and we are the next bit field. So we can work us through this table, and then we actually want to extract data later. So let's look at one of these offsets. The first one is obviously 0, so very at the start here. But as this is uncompressed, there's still some header stuff here, obviously, which we have to skip. And 4a should be exactly the content size. So this is uncompressed. And so I have extracted some examples. That's all the data for it. I just need the offset essentially, and can read from here. It works like for the uncompressed header, offset, compressed size, uncompressed size, and then I think this is a boolean, not quite sure. We have a hash, then we get a count, that should, or another boolean, and then I don't know why this has to be skipped, and then for a data, that is actually the content. For a compressed one that has just one block, I have this example. We again start from 0, and compressed it's AF1. I already know where this starts, I think. give me a second, 49 is here, to the end is length of 1FA. We also, the block also goes from 49 to B39, and that's what we have here, 49, 3B1. How does this work? I can skip a lot of stuff here again, but I have the same offset, compressed, uncompressed size, which I don't even need yet. If this is true, we already know it's I think this is a compression method, so for the other example this would have been 0. And again this hash, and this time we have compression blocks entries. So these work by start offset from this offset where we at, and end offset to where we go. That's what I just showed. And if I have an entry that has multiple entries like this, so for example this one, it's at 1F, E7, then let's copy this out, just the start of it. This works similar again, offset, it's always 0, compressed size, uncompressed size. This is compressed, so compression method, the hash, and now we have 4 such blocks starting at 79 from the start to this end offset, start offset, end offset, and so we have 4 of them. And if I look at the data, where is this is 79, and then there's binary data following it. Looks compressed and fine. Okay, so what does it mean? I have to, I'm actually still at reading an entry. Let's implement that now. Whew, talking a lot. Let's do something. So we are at the place that that's the entry for this file particularly sent us, and first we read the bit field. So okay, let's ignore all of that for now. Long offset in the actual file /0. So this is how you can check that. So if the highest bit or the second highest bit is 1, this is 32-bit safe. Should probably write a method for that. Yeah, actually I can do this in one line. Oh, we read 64-bit. From the 30. Would be the uncompressed size. Let's make it shorter. Uncompressed size. Okay. Then we need the compression method, which is this little term here. Okay, multiple things. All right. So here's the method. Actually, let's get this out first. This can be stored in a byte. Compression method index. So as far as I understand, if this is 0, then it's uncompressed. Else we have to actually use the compression. Compress method. I already have that actually. Compress method. I don't even read compression blocks yet. Yeah. Just need to know if the method is 0 or not. Oh wait, actually, why do I make up new variables if I already have it? Then definitely the compress size. And we don't have to do any further thing from reading this. All the reading at the actual address will be done later. But if we have a method, we don't actually care which one yet. Then we definitely read the uncompressed size. Uncompressed size. Yeah, 29. So it's a third bit from the top. So this is a compressed size. Yeah, I should rename this compressed size, uncompressed size. It's a bit clearer. So we take this and then we have to know how many extra offsets, which I will just ignore. You int, what was it called? Compression block count. Okay. C block count. Field to right. Okay, and let's skip that. 4 times our count. from where we currently are. Happy now? Okay. We have this entry and fine. Also, going back to our directory entry, it always tells us the starts. We don't even need to pass everything perfectly. There's the next file. EB6C. Yep, always starts as a flex. Okay, so I don't even need that. And for the compression blocks, yeah, these I will need later. Compression blocks. Yeah, we can actually already read the compression blocks. That would be an idea. Okay, but then I need access to the file stream. So table. File stream. Okay. If I have access to the what? File stream, okay. I can actually go ahead and just read them. So because I'm lazy, I will just skip all of this. So this should be fixed for uncompressed. Do I want to? Do I not to? I don't need any of that right now. I only need these ones here because they give me offsets. Right, and they still start so and so far after the start, so 30 hex. 30 hex. Okay. Ooh. Seek to our position from the start. And we add 30x and see block count. Now we just read our compression blocks. Great. This. I don't know where to get encrypted from. I guess not. Do I want to read the hash? Not really. Okay. And read it. So I have everything together later. Okay, copy sexual data is this part. Wow, this is a lot. Let's try it out. Let's see if we can at least read everything in now. Not even exporting yet. Okay. Copy new. Okay, gonna cut this out. That's some wild trickery with bit flags and stuff. Very confusing. This one has a lot. Huh. Loading domino. Okay, here we are again. That's the breakpoint. Wait, did it not notice I updated the code? Succeeded, was copied. Just to be sure. Everything is here. Well, maybe because I haven't triggered it yet. Okay, what's this file? That is our Windows 0 pack. Okay, let's go into it. Mount point. It's just nothing. Okay. Skip that. And we already failed. Okay, that was quick. Okay, that was quick failing. We have the mount point. We have the file count. Oh yeah, I forgot to skip something in between. Yeah, between this bool and the next bool is supposed to, yeah, 36. Okay, so much for that. Yeah, you can just let this run and figure out this is not working. Okay. File table. Pack file. Am I stupid? Yeah, here was it. Okay, let's try that again. And here we are again. Next attempt. Oh. Fiction. Let's read our file table. Mount point. Fine. Fine. Directory offset. Directory size, correct. This is not correct. We skip 20. 1094. Yeah, wait. That is definitely wrong. Here offset. It's already wrong. What? Where does this data come from? So we verified this. What the hell did it read here? Wait, is this another file? Uh-huh. Why? Okay, but never mind. It should still work. Is this still true? Directory buffer, okay. How many directories do we have? 8, okay. File count. A lot. What? Oh, okay. Offset. That is fine. Now we read our first entry. File name is what? How does this arrive? Mount point. Directory name. Oh, so I see I have to remove the trailing slash on mount point. Okay, let's ignore that for now. Okay, we have our bit field. That looks good. Position fine. That is fine. Not compressed. And done. So this would be, let's take a look. First entry is too simple. Wait, this is another file. Shit. So wait, it read all everything. That is great then. Give me a file table then. Entries 90. Wait. This looks good. Why is there no file name? It does read stuff, so there's that. Uh-oh, this is probably not good. Okay. Component. Oh, I see a problem. This should be file count, not... Ah, damn it. Will it crash? Didn't? Okay. That's a bad mistake. Okay, and also fix this deal name. Endpoint ends with slash and deal name starts with slash. We skip that. Okay. File count. Great. Let's try that out. And here we go again. Lucky for you, I can cut this in the video. And we are back. Now with the updated code, let's try that again. Oh shit. Okay, we get a breakpoint. A lot of audio. Okay, that is fine. Okay. Let's get out of here. Okay. So I'm not sure if this is just very slow or there are just many files. Okay, let's read the whole table. That was quick. It's quite a lot of entries. Will Visual Studio display it or not? Find out next. Oh, doesn't seem to want to. Alright, then try with the next one. I mean, you can understand that this takes a while. If these are 11 gigabyte files, gigabyte sized files. Whatever. So how's this file table? Still a lot entries. Nope, not displaying it. Just too many files. Well, okay. Can actually go through them pretty fast. Okay. This means we are pretty much at the end for being able to display them. That would be in our registry, the fresh loaded files. Yeah, that's something I have to do in the next episode. I'm just happy I can read all the files now. This is quite a lot, and actually finished it. Okay, sorry for meandering here. This is not so visual as usual to see what the result is, but let's just to drive it home, show it again. Maybe just load the just single file. Yeah, they are gigabytes in size, which is the smallest one. UTalk pack. Wow. Okay, let's try this one. So load a few of these. And what have we got so far? That looks great. I think I will overwrite the display so we can actually see the files. Okay, so last update for today. Okay. So if that works, next episode we will be able to actually export data. Man, that took a lot longer than I expected initially, but yeah, here we are. And let's test it again. Entries, slow review. I mean, these file names are pretty boring. But yeah, this looks correct to me. Let's load another one. Maybe not just audio files. How about a big one? And there you have it, internal files. This is great. Okay, well, not much to show this time, except the way how I got here. And hopefully next time I can show you how these files actually look inside. For now I can at best show you how they look in hex. If I have an uncompressed entry like this, so you can already see this is definitely readable. And yeah, let's explore files. Thank you for watching, and see you next time. Bye.